All right. Good morning, everybody. So, welcome sa week number 7 ng semestre, and I think this is the last week before we go to the reading break. Tama nga ba? Kasi sa Monday ay reading break na. So, if that is the case, then good news for you guys. Wala tayong laboratory exercise, obviously, on Monday. All right. So, makakapahinga kayo ng konti. And I will not give you too much of hindi, mali pala. Kasi mag-expect kayo na walang gagawin. Pero anyway, so let's just first get our schedule straight. Ano? So today, October 19, we'll finish module number 4. And then I'm thinking of not introducing any topic on the 21st para siguro we can take an early break on the 21st kasi medyo alanganin if I will start module number 5. What I'll just do is to put module number 5, which is about curve fitting, to be a reading assignment which you can do for your project. So para hindi na natin siya titingnan because I'm looking at the course guide, nakain ko na yung week na para sa curve fitting kasi week number 6, October 10 to 14 should have been for module number 5, which is curve fitting. And then this week is supposed to be a buffer week. So kaya lang di pa natin natatapos yung module number 4. So here's what I'm proposing. So today we'll finish module number 4. It will just be a quick discussion. And then module number 5 will just be an optional reading for you. You can remember we do have a final project for the course. So you can do your project as you can do your project by applying concepts for module number 5, which is about linear fit, quadratic, exponential fit. Pwedeng ganun yung gawin nyo sa final. I-apply nyo kung ano man yung nasa sulat sa module number 5 to say some real-world data, say stock prices, or what kind of statistics interests you. Lang. And then I will not start anything new on Friday. Kaya lang, on Friday, I'll give you problem set number 1. So maybe I should write that down here para maalala ko rin, ano? So I'll release problem set 1 on Friday. That's at the 21st, 10/21. And then we don't have any lecture class. No lecture class. 10/21. Mukhang nagfe-fail yung internet kasi sa iPad. Hold on. Lumipat siya ng network. Bakit gusto ko dun sa kabilang wait, there we go. Laging gusto ng iPad ko dun sa kabilang Wi-Fi. Okay, and it's not updating anymore. But here's what I'm proposing again. I will release, there you go. I will release problem set number 1 on the 21st, probably around noon or late in the afternoon. So expect it to be released by then. No lecture class on the 21st kasi natapusin na natin ngayon yung module number 4. Module number 5 is optional reading. And then when do you think you can submit the problem set? Okay, here's the thing. Of course, I cannot compel you to do anything on the reading break. Supposedly, wala tayong gagawin ng reading break. So that means I will not require you to submit it right after the reading break. So siguro I'll give you another week after the reading break. So is it okay if I say kailan? Hold on, let me just think about it. Can you submit it on October 30? That's a Sunday at the latest. Ano? Is that okay? All right. That's a Sunday. But if you're avoiding working on the weekends, then target to finish it by the 28th. All right. So, mangyari sa ibibigay ko yung problem set sa 21. Right? Teka, masyado yatang maiksi. Hindi, reading break pa pala tong 30, sorry. Tama ba? Kailan yung reading break natin? Ang reading break natin ay 22nd hanggang 20... Hold on, tingnan ko yung calendar. Ang reading break natin ay 24 to 28. October 24 to 28. Mali nga yung bilang ko. So, reading break tayo ng 24 to 28. You're not expected to do anything by then. October 31st is a holiday. So, November 6th, I think. Yeah. Ang deadline niya ay November 6, 11:59 p.m. Alright? Okay na ba yan? Tama na ba yung bilang ko? Kasi ang assumption ko, dapat wala kayong ginagawa ng reading break. Tapos I'll give you another week to do this after the reading break. Doon ko pala kayo na-expect magsimulang maggawa nito. Pero ibibigay ko na siya sa Friday para dun sa mga workaholic dyan and you want to catch up with your ACADS, ano, pwede nyo siyang gawin kung gusto nyo lang ng problem ng reading break. Alright? Pero hindi ko kayo sinasabing gumawa ng reading break. Okay? So it's gonna be how many? There will be 3 parts to the problem set. Part number 1. Part 1 is essay. So number 1 is a 10-point essay. Probably I'll give you 5 quick questions that you will answer in 2 to 3 sentences each. So 5 tanong, 2 to 3 sentences. Ang sagot nyo sa bawat isa sa kanila, 2 points each. So that's 10 points. All right. I just want you to answer some conceptual questions, explain some things, or say some things in your own words, ano? So, pero I trust that kaya nyo naman siyang i-explain, ano? At yung mga conceptual. Then, problem number 2 could be a, say, either approving or a quick computation question. All right? So pwedeng halimbawa, magtatanong ako tungkol sa upper bound. Halimbawa, ilang ilang points dapat yung gamitin nyo dun sa interpolation para yung error ay hindi lalampas ng ganitong number. All right? Or what if I'm using piecewise linear interpolants? What should be the maximum value of h such that hindi lalampas yung error sa ganito? Or pwede ko namang ipa-prove halimbawa na yung mga, ano ba pwede ko ipa-prove? Pwede ko ipa-prove na yung mga Legendre polynomials ay orthogonal to each other with respect to the weight function w which I will give. All right? So, pwedeng ganon. Ito yung mga easy computations or proving questions. All right? And then the third part would be a computational part which basically go back to one of the methods that we talk about that was least explored in the laboratory exercises, and then I'll ask you to do a computation. So parang ito yung isang problem sa lab exercise. Meron talagang data, tapos i-apply nyo full-blown ng isang method na hindi natin masyadong na-explore sa laboratory classes. So each part will be worth 10 points each. Okay? Any questions? So okay na ba? November 6 yung deadline. November 6 yung ginawa kong deadline, Sunday, kasi November 7 meron kayong laboratory exercise. Ayoko na siyang pagsabayan. Natuto na ako dun sa laboratory exercise, yung dalawa nating lab exer which was due both on a Monday. A lot of you didn't make it, didn't submit both during the deadline. So parang medyo mapilitan kayong paghiwalayin yung paggawa sa kanila. Ano? So, alright. Kasi holiday ng 31 eh. So, wala tayong pa-exer ng 31. So, I hope that's fine. Okay? Any questions? Any reklamos? Okay na ba yan? Alright. So, if that's the case, then that settles it. Ano? And then, over the reading break, usually talagang nag-hibernate ako, so kaya ayoko rin na kayo ay may ginagawang masyadong marami in my courses. and everything, working on my courses will be optional during the reading break kasi ako nga hindi nagtatrabaho. So hindi ko ine-expect na kayo ay magtrabaho. Pahinga lang talaga and time for reflection. So what I do during that time, I nagre-reflect with the past semester, with the past half semester. Titingnan ko kung ano na yung nangyari sa klase natin, and I'll try to look at your works and see how you're doing. So if you want, you can give me a mid-semester assessment of what you're doing. Probably siguro, yeah, gawin ko nga siguro ng lab X or something. Ano, I'll just make kumusta you. Napakonyo, no? Kukumustahin ko lang kayo siguro over the reading break. Sige. Kasabay nung problem set number 1, meron uli akong kumusta homework or kumusta lab exer just to see how you're doing, this past semester. Okay. So watch out for that on Friday then. Pero ang deadline siguro nun mas maaga. Hingin ko siguro siya ng November. Halos 2 linggo pa lang ating reading break, ano? Kasi holiday ang October 31, holiday ang November 1, special working holiday ang November 2. So November 2 na tayo magkikita-kita after today. So siguro i-juju ko na siya ng October 2 afternoon, yung kumusta question, ano? So, pero mas okay sana kung i-submit nyo siya sa akin ng reading break, ano? Para mapagnilay-nilayan ko siya during the reading break. Ano lang naman siya, walang computation, sulat lang kayo, parang journal lang, ano? So, para tumama dun sa aking reflection period. Okay. And then yung mga advice ko dyan, siguro, if you want, you can also consult. Medyo behind ako dun sa mga SPs nyo, alright? So, hindi, wala pa naman nag-SP sa akin, mga nagwa 195. So, pwede nyo akong kulitin during the reading break if you're working on your math 195. Pwede nyo gamitin din yung time na yun. Alright? Pero anyway, so that's it. Actually, kagabi ko lang naalala na okay, thank you, Nicolate, for telling me na napuputol ako. Sorry kasi naka-on yung calendar ko, natakpan yung meeting chat. But I hope I'm more stable now. I mean, my internet connection is more stable now. Okay. Yeah. Actually, kahapon ko lang naalala na kailangan na pala nating mag-problem set. And then I checked the course guide. Yun nga, buffer week na tayo dapat ngayon. Tapos sa tapat tayo ng module number 5. Pero you know naman, hindi naman tayo nagmamadali. It's better to, sorry, excuse me. It's better to take things slowly but surely, Okay, now, tapos na yung introduction. Let's go down to business. I think tama ka ba? No, Friday hindi tayo nag-meet live, Tama nga ba? Hold on. Yeah, because I think that was the time that I was in Laia for the graduate school workshop, So I hope you watched the video recording that I asked you to watch during our lecture time last week or last Friday. Okay, so it covered the rest of piecewise linear interpolants. So dun sa piecewise linear interpolants, I doon sa video na yon, dinerive kung paano kinukuha yung formula para sa piecewise linear interpolants. And I think that was pretty straightforward because yung pagkaka-derive ng equation o ng formula para sa piecewise linear interpolants ay nakabase dito sa tatlong conditions na yan. Tatlong conditions dun sa definition ng isang PLI. PLI or piecewise linear interpolant. Dapat yung piecewise ay yung conditional function natin ay daraan sa lahat ng data point. So requirement number 1 is the interpolatory requirement. So dapat sakto pa rin. Next is S is continuous on the closed interval AB. Ibig sabihin yung dalawang magkadugsong na piraso nung PLI ay dapat parehas yung function value. Alright? And that's easy to realize. Ang nangyayari lamang ay halimbawa na kay x sub na kay x sub na kay x sub I f of x sub I tayo. Alright? So this should be this is a point on the graph of the function that we need to interpolate. So by the interpolatory requirement or number one in the definition of PLI, dapat daraan dito yung piecewise linear interpolant. All right? And then yung number two is the continuity condition. Ibig sabihin, kung meron kang piraso rito, this is our what? This is S sub I. This is S sub I, hold on, S sub I minus 1 or S sub I plus 1? Ano yung ginamit ko? Yeah, X sub I plus 1. Alright. So, tawagin ko itong, adjust ko lang para eksakto siya dun sa derivation na ginawa ko, alright? Tawagin natin itong si X sub I plus 1, tapos function value ni X sub I plus 1. Okay. Pwede ko namang minus yung plano ko. Pero anyway, para lang katulad nung nandun sa derivation, right? So we consider a point x sub I plus 1, comma f of x sub I plus 1. And this is really needed to be in the PLI because of the interpolatory requirement. So dapat daraan yung spline natin sa point na yan. And remember, condition number 3 tells us that we are simply pasting together linear functions. So linear function yan na magkadugsong. Now, number 2 requires continuity of the piecewise linear interpolant, meaning dapat etong piraso na to is S sub I, that's a linear function, and then this is another piece of the conditional function, let's call it S sub I plus 1. So si S sub I, siya yung nag-govern dun sa linear interpolant sa interval x sub I hanggang x sub I plus 1. Si S sub I plus 1, siya naman yung nag-govern dun sa interval x sub I plus 1 hanggang x sub I plus 2. Alright? Tapos continuity requirement, dapat parehas sila ng function value doon kay x sub I plus 1. Alright? And then from that, from the interpolatory requirement and the continuity requirement plus the linearity of S sub I and S sub I plus 1, you could get this formulas, ano? So ito dapat yung intercept noong piecewise linear interpolant. Ito dapat yung slope ng piecewise linear interpolant. And I guess you already did this kasi ito yung tanong dun sa laboratory exercise kahapon, nung Monday. All right? And then also look at theorem 4.1. Medyo tinanong ko na to dun sa laboratory exercise natin kahapon. So, maliit na yung chance na ito yung nasa problem set, so kasi natanong ko na siya. Maybe watch out for other theorems na posible kong itanong dun sa part 2 ng problem set. Okay? And then part of the video that I ask you to watch would be for cubic splines, So hindi ko na ngayon dadaanan yung algebraic calculations or algebraic steps para makuha yung unang 4n minus 2 equations nung cubic splines. All right? So I trust that you watched that recording. If you haven't done so, you can visit the recording page natin kay Canvas, and then tingnan nyo dun yung 11.2. All right? Yung recording for meeting 11.2. Kasi ngayon, didiretso na ako dun sa mga klase ng cubic splines. Pero just a quick recap. Okay? So tingnan mo uli natin, ano yung definition ng isang cubic spline? Right? So basically, or before going even to cubic splines, alright? So dun sa piecewise linear interpolants, nagdudugsong-dugsong tayo ng mga linear functions, So if you want to go one step further, just a little bit from PLIs, pupunta ka na dun sa pagdidikit-dikit ng mga quadratic functions. Ang tawag na natin sa kanila ay quadratic splines, right? So ang splines, ito yung mga piecewise interpolants. So ito yung mga interpolating functions na conditional functions, all right? Tapos na smooth. So dapat smooth or different continuous yung at least first derivative para matawag ka na spline, right? So yung ating piecewise linear interpolants hindi sila tinatawag na splines kasi yung piecewise linear interpolant posible na hindi differentiable kasi pwede kang magkaroon ng sudden turn dun sa dun sa bawat interpolatory node. So, hindi siya smooth. So, hindi spline technically yung piecewise linear interpolants. Kasi ang splines, dapat sila ay mga conditional functions na interpolants, pero dapat sila ay smooth. Meaning, up to some point, they do have continuous derivatives. Okay? Ang pinakamaliit na example ng splines ay yung quadratic splines. So the idea is the same as piecewise linear interpolants, ang pinagkaiba lang, ang pinagdidikit-dikit natin ay mga parabola. So between two consecutive points, halimbawa, ito yung function value at x sub 1, function value at x sub 2, function value at x sub 3, ginagawa natin, nagdudugsong-dugsong lang tayo ng mga quadratic functions o mga parabola. Ay, pero dapat smooth, no? So dapat ito ay medyo pa ganyan. So bawat piraso, yung S sub I, yung S sub I plus 1, at lahat ng mga piraso nung quadratic splines ay mga quadratic functions. And the way we derive piecewise linear interpolants and what was done to cubic splines can be applied to quadratic splines. So isa ring posibleng topic nyo para sa project ay paggamit ng quadratic splines. Wala siya sa modules pero madali siyang i-google. Google nyo lang quadratic splines, ano yung definition niya. From there, you can find how to derive the quadratic splines. So, posible nyo siyang gawing topic para sa project, right? But I will not discuss that in class. Didiretso tayo dun sa pangatlo, yung cubic splines, all right? So ang idea sa cubic splines ay the same as PLIs and quadratic splines. Ito ang gagawin natin. Pag didikit-dikitin natin ay mga cubic functions with lots of conditions, with much more conditions. Bakit mas maraming conditions? Kasi mas marami tayo ditong degrees of freedoms. Okay? So basically, a cubic spline interpolant of f relative to a partitioning of the interpolatory interval is a function that satisfies 5 things. Kasi quadratic, cubic na yung pinagdidikit-dikit natin dito, marami tayong freedom. Kesa dun sa piecewise linear interpolants lamang. So una, sa bawat subinterval, dapat si S ay isang cubic polynomial. So ibig sabihin, ang itsura nito, yung ating cubic spline ay S of X equals piece number 1, S sub 1 of X, piece number 2, S sub 2 of X, hanggang S sub n of X. Kasi nga, kapag ka meron kang n plus 1 na interpolatory abscissas, hinahati mo yung interpolation interval into n subintervals. Tapos sa bawat subinterval na yon, meron kang condition o meron kang function. Alright? So ito yung si S1, ito yung nag-govern kay X1 hanggang kay X2. Si S2, siya yung nag-govern mula kay X2 hanggang kay X3. And si Sn, siya yung nag-govern sa interval x sub n hanggang x sub n plus 1. Alright? And condition number 1 in definition 4.2 tells us na bawat isang S sub I dapat ay isang cubic polynomial. Right? Or it should be a polynomial of at most degree 3. Pwedeng mas mababa, lalo na kung magzi-zero yung ibang coefficients, pero hindi na siya lalampas dapat ng pagiging cubic polynomial. And again, we're doing this in order to avoid the Runge phenomenon. All right? Kasi nga, natutunan natin in section A of this modules na kapag ka masyadong malaki yung degree ng polynomial, nagwi-wiggle yung interpolating function. Kasi nga, paglaki ng degree, pagdalas ng pagkakaroon ng zeros, so malaking chance na nag-oscillate yung ating function, yung ating interpolatory function. That's why we don't want our interpolating function to be a polynomial of very high degree. So, ang ginagawa natin, okay, sa splines, ang solution natin, magdikit-dikit tayo ng mga lower degree polynomials. So, that's what we're doing here. Bawat isang piraso kay S ay dapat ay isang cubic polynomial o isang polynomial na hindi lalampas sa 3 yung degree. So that means each of the S sub i's here will be of this form. So S sub I will be equal to A sub I plus B sub I times X minus X sub I plus c sabay x minus x sabay squared plus d sabay times x minus x sabay cube. So dapat ganito yung itsura ng bawat s sabay natin. Alright? So medyo ganito ko siya sinulat kasi mas madali yung derivation kung ganito yung form. Kung naka-minus yung x sabay. Kasi di ba ang general na cubic pwede namang ai plus bix squared plus cix cubed na wala yung dix. Alright? So pwedeng ganyan lang yung itsura pero mas madali yung derivation kung ang gagamitin kong base ay x minus x sabay. Para pag nag-substitute ako dito ng x sabay, magzi-zero to, magzi-zero to, magzi-zero to. So yung interpolatory requirement lang natin, yung ai, ay equal dun sa mga f of x sabays. Alright, that's the only reason why I chose why I chose x minus x sabay to be the base for the powers of the variable. Okay, para pag nag-plug in ako ng x sabay, matitira lang ay si a sabay. Right? Makikita nyo mamaya na yung a sabay, siya yung mga f of x sabays. So that means, for each of the n pieces of my cubic spline, meron akong 4 na degree of freedom or 4 na degrees of freedom. Sino-sino sila? A sabay, B sabay, C sabay, D sabay. So yung paghahanap ko ng cubic spline ay nagbo-boil down sa paghahanap ng 4 na number sa bawat isang piraso. Alright? Hanapin ko ano dapat si AI, ano si BI, ano si CI, ano si DI. Alright? So, ibig sabihin, in all, we need 4n coefficients para ma-completely determine ano yung itsura ng cubic spline natin relative to the partitioning of the interpolatory interval. We need to have 4n numbers. Okay? So, sino-sino sila? Etong mga coefficients na to. Yan yung kailangan nating i-compute para sa bawat isang I going from 1 to n. So, we're looking for 4n numbers. Now, saan manggagaling yung 4n equations na yon para sa 4n numbers na to? Manggagaling sila dun sa conditions 2 to number 5. Well, condition number 2 tells us dapat daraan ka dun sa bawat point x sabay, f of x sabay. Alright? So, kailangan pag nag-plug in ka rito ng x sub I, dapat equal yon sa f of x sub I. Alright? Pero ito nga yung dahilan kung bakit pinili ko na x minus x sub I yung base. Para pag nag-plug in ako ng x sub I, ito ay magzi-zero, ito ay magzi-zero, ito ay magzi-zero, and boom, a sub I equals f of x sub I. So, alam na natin yung mga a sub i's, alright? But the interpolatory requirement will give us how many? This will give us 4n. It will give us 4n equations na pwedeng masatisfy. Okay? And then, itong conditions 3 to 5, ito naman ay continuity. Ito lang yung in-impose natin dun sa cubic splines. Dapat extra smooth siya. So, ibig sabihin, si S ay gusto ko maging continuous, pero hindi ako tumigil doon. Gusto ko si S prime ay continuous din, at saka si S double prime ay continuous din. Alright? So, if you watch video 11.2, so you already know what happened here. In-implement lamang itong conditions 3 to 5 to get another set of equations para dun sa mga unknown coefficients A1 until DI. Alright? But you will see that there's a problem here. We are looking for 4n unknowns, right? Or the 4n degrees of freedoms. Ito yung mga AI, BI, CI, DI. There's a total of 4n that we need to find, right? However, if you write down the equations coming from conditions 2 to 5, nun definition 4.2, you will have only 4n minus 2 equations. So that means mas marami tayong unknowns kesa sa equations. So ibig sabihin, there will be infinitely many solutions. Kasi mas marami yung degrees of freedom kesa dun sa ating mga equations. So to completely or to uniquely determine a cubic spline, kulang tayo ng 2 equations. So we are free to give 2 more conditions out of our wants, or kahit anong maisip nyo na 2 conditions that will be independent from the existing 4n minus 2 conditions to completely determine yung cubic spline. Kasi meron pa tayong additional degree of freedom. Pwede ka pang magdagdag ng 2 conditions aside from definition 4.2. Kasi nga, yung definition 4.2, 4n minus 2 conditions lamang or equations yung ibibigay niya. Pero 4n yung degrees of freedom. So pwede pa tayo magdagdag ng dalawang conditions para ma-uniquely determine natin yung cubic spline. And this is one big departure of cubic splines from piecewise from linear interpolants, piecewise linear interpolants, and even sa AIP. Kasi natutunan natin from the unisolvents theorem, kapag ka given ka ng x1 hanggang x sub n plus 1, unique yung algebraic interpolating polynomial na daraan of degree at most n na daraan dun sa n plus 1 points na yon, right? Tapos, it's easy to show that unique din yung piecewise linear interpolant na daraan dun sa n plus 1 points na yon. Pero kapag ka cubic splines na yung usapan, wala na tayong uniqueness ng solution. Okay? So we can always find a cubic spline that will pass through any set of n plus 1 data points. Pero hindi yon unique. Bakit hindi siya unique? Yun nga. Kasi yung definition ng cubic spline will give rise to only 4n minus 2 conditions or equations, but we do have 4n degrees of freedom. So kulang ng dalawang conditions para ma-uniquely determine siya. So sa isang set of data points, posible kayong makakuha ng napakaraming cubic splines. All right? And the goal of the remainder of our class today is to take a look at some of the common choices for the two missing conditions na pwede nating ibigay para makakuha ng iba't ibang klase ng mga cubic splines. Okay? So pwede ko pala itong itanong sa problem set, sa essay part. What's the major difference of cubic splines from AIPs and PLIs? Ano? So sabihin nyo lang naman, hindi unique ang cubic splines kasi sa isang set of data, okay, hindi lang unique yung cubic spline na dumaraan doon sa data points na yon. Hindi katulad ng AIP at ng PLI na unique lamang yung interpolatory function. I mean, yung AIP at yung PLI na daraan doon sa lahat ng mga points na yon. Okay? So at least nagkaka-hint kayo no kung paano yung tanong ko sa essay part. Pero if you Pero if you have taken 155 or what? Ano pa nga ba yung tinuro ko? 101? Sa 101 ba? Hindi ko matandaan sa 101 kung nagpapa-essay din ako. Pero in general, ganun lagi ako nagpapa-prob set. Ano? Okay. So, let's go forward. Ito yung sinasabi ko na nitty-gritty na makikita nyo sa video 11.2. So, tinranslate ko lang into equations yung conditions 2 hanggang 5, yung definition 4.2, you'll get these equations, 4.3 to 4.6. Si h sub I, siya lang yung step size. Siya yung difference between two consecutive abscissas. Then you'll get 4.3 to 4.6. Tapos a bunch of calculations. Kayang-kaya nyo namang sundan yung derivation dyan. Naka-specify naman siya dyan. Makukuha nyo si 4.7, si 4.8, si 4.9. And I guess the star of this discussion is 4.10. So yung conditions 2 to 5 na tinranslate into equations 4.3 to 4.6 was reduced into an equation, namely equation 4.10, that involves the C sub i's. All right? And that system is written in matrix form here, equation 4.11. So dito nyo makikita na kulang talaga ng dalawang conditions para ma-completely determine natin yung mga cubic splines. All right? Kasi rito, ang goal mo mahanap si C1 hanggang si C sub n plus 1. Alright? Remember, si C sub I, siya yung coefficient ni x minus x sub I squared. Now, kunwari, kompleto na to. Halimbawa, nalagyan nyo na yung first row at saka yung bottom row. Kulang tayo ng dalawang conditions. So, sila yung mga ilalagay natin sa first at saka sa last row. Itong matrix equation na ito. So, these are itong coefficient matrix completely determined yan kasi ang kailangan nyo lang naman dyan yung mga h sub i's. Ano yung difference between two consecutive abscissas, Dun sa interpolatory process, laging given yung x1 hanggang x sub n plus 1. Pag alam mo yung x1 hanggang x sub n plus 1, makukompute mo yung h1 hanggang h sub n. Sila yung kailangan mo para ma-fill up yung entries ng coefficient matrix A. Tapos ang unknowns, ang mga unknown dito ay mula kay C1 hanggang kay C sub n plus 1. So si C sub n plus 1, ano lang yan, parang dummy variable. Hindi nyo yung kailangan para ma-compute yung S sub n. Kasi si S sub n, ang kailangan mo lang naman ay si C sub n. Alright? Now, tapos ito, mga A sub i's lang naman yan, pero mula dun sa derivation kanina, yung A sub i's sila lamang yung f of x sub i's. So this guy is also completely determined. So in this linear system, you have AX equals B. Pag na-define nyo na ito kay MATLAB, ano yung itsura ng matrix A, ano yung itsura ng vector B, pwede nyo nang ipakompute yung vector C or itong vector X na to consisting of the C sub i's using this. X equals A inverse B. Or kay MATLAB, so i-input nyo na si A, ano yung itsura ni A, so tatype nyo yan. Or meron kayong for loop para automatically ma-populate yung matrix A. Tapos itong si matrix B, i-type nyo rin yan. Pag na-type nyo na sila para ma-compute si vector C, alright, ang command lang ay, maraming pwedeng commands. So, pwedeng gawin yung command ay inverse of A times B. Alright? Kasi kapag meron kang AX equals B, tapos si A ay invertible, meaning may inverse si A, you can apply A inverse to both sides to the left. So I'll apply A inverse AX equals A inverse B. Alright? Associative naman ang matrix multiplication. So instead of grouping A and X together, you can group A inverse and A together. A inverse times A is just the identity matrix. Identity matrix times X will just be X. So equal kay A inverse B. So ito yung kailangan yung computan kay MATLAB. Ito yung magko-contain ng mga C sub i's. So one command to do that in MATLAB is C equals inverse of A times B. Or medyo mahal mag-compute ng inverse kung malaki yung coefficient matrix A, mas okay na ito yung gamitin nyo. C equals P-inv. P-inv stands for the pseudo-inverse. Okay, so wag niyo munang isipin ano yung pseudo-inverse, pero alternative solution to. Sa 175 ko pa usually dinidiscuss yung pseudo-inverse in definition niya. Pero ito yung parang kahalintulad ng inverse ng isang matrix. Alright? Pero ito yung mas computationally efficient. Tapos star B. Or, ang pinakamaiksing command ay si C equals A backslash B. Okay? So, pare-parehas yung sagot na ibibigay sa atin ng tatlong commands na yan. Okay? After that command, so ibibigay sa iyo ni MATLAB si C1 hanggang si C sub n plus 1. But remember, ang hinahanap talaga natin ay ang mga AIs, BIs, CIs, at saka DIs. Pero dun sa first step, dito sa linear system na to, mako-compute nyo pa lang ay yung mga C sub i's. How do you compute for the other coefficients dun sa ating cubic splines? Babalikan nyo yung mga equations kanina. Now, from equation 4.7, you can compute for the DIs, right? Kasi after nung linear system, alam na natin lahat ng mga C sub i's. Alam na natin before ano yung mga H sub i's. So makukuha natin yung mga coefficients D sub I ng x minus x sub I cube. So makakompute nyo yung mga DI. Oh, by the way, yung mga AIs, alam nyo na rin. Kasi yung mga AIs ay equal lamang kay f of x sub I. So ano na lang kulang? Kulang na lang yung mga BIs. Pero yung mga BIs can be computed using this. Kasi alam na natin yung mga AIs, alam na natin yung mga CIs, alam na natin yung mga HIs. So 4.8 can be used to compute for the B sub i's. And this is the reason why I want to compute C sub n plus 1. Kasi si B sub n, alright, pag ito pinalitan ko si I equals n, tingnan nyo to. Ito ay magiging C sub n plus 1. Kailangan ko si C sub n plus 1 para mo-compute si B sub n. Kahit na wala namang C sub n plus 1 kasi hanggang S sub n lamang yung hinahanap natin na piece. Alright? So pag-isipan nyo kung paano to i-implement, alright? Sige na nga, baka sa problem set, cubic spline yung nasa part 3. So sa yung PS 1.3 natin is about cubic spline. Okay. Para hindi na ako magpapa-lab exer about cubic splines. Swerte nyo, no? Ang dami nyo na save, ano? So, yeah, pag-aralan nyo na lang to para sa problem set, ano? Kasi super off na yung susunod na lab exer. Inisip ko, kasi nga nag-holiday ng 31 eh. So, November 7 na yung next lab exer. Eh, makakapag-discuss na tayo ng chapter 3 sa week after the reading break. So, yun na lang yung papa-exer ko nun, okay? So, tutukan nyo to para sa problem set 1.3. Kailangan nyo kasi ditong i-input at least ito. Yung coefficient matrix except the top and the bottom rows. Kasi mainstay naman to. Kahit anong klase ng cubic spline, yung hinahanap nyo, lagi nyo kailangang isolve itong linear system na to, na ito yung second up to the last row. Mainstays yan. Hindi yan nababago. Kahit anong klaseng cubic spline, mainstays ito dun sa ating equation. Ganun din itong right-hand side. So pag-isipan nyo na, paano nyo efficiently mapapagawa or ma-automate sa inyong programming language yung pagde-define nitong mga rows na yan. Well, it's a tridiagonal matrix. Ang meron lang laman ay yung main diagonal. So ito yung main diagonal at saka yung dalawang main off diagonals. So, and then the rest would be zeros. Yun lang yung meron. Possibly except the first and the last row. So first and the last row, free kasi kayo na magbigay ng any condition dyan. Pwede nga mag-imbento kayo ng sarili nyong cubic spline. Sabihin nyo lang, gusto ko, halimbawa, si C sub n plus 1 ay equal kay H1. Or si H1 C sub 1 ay equal kay 1. So bahala kayong magbigay ng first at saka last row dito sa magkabilang side, alright? Then you'll get a cubic spline. Of course, if you put in reasonable assumptions, na magkakaroon ng solution yung linear system. So you can make your own brand of cubic splines actually. So bahala kayo. Pwede kayong magbigay nun. Pero ang i-discuss ko ngayon ay yung mga common choices for the cubic splines. So ipapakita ko yung mga conditions na pwede nating idagdag dun sa top row at saka bottom row ng ating coefficient matrix at ng vector of constants dun sa ating linear system 4.11 to completely determine a cubic spline. At unang-una na to, kapag wala ka ng ibang information about the function you're interpolating. So halimbawa, ang given lang talaga ay bunch of points, x sub I, comma, f of x sub I. And nothing more is said about your function f na gusto mong i-interpolate. Ang go-to kind of cubic spline ay yung tinatawag natin na not-a-not cubic spline. Okay? So, yung not-a-not cubic spline ay gumagamit ng not-a-not boundary conditions. Ano yung not-a-not boundary conditions? Dapat yung d sub 1 ay equal kay d sub 2 at saka yung d sub n minus 1 ay equal kay d sub n. Ibig sabihin, equal yung coefficients ni x minus x sub 1 cubed at saka ni x minus x sub 2 cubed doon sa ating spline. Alright? Dapat equal si d1 saka si d2 at saka si d sub n minus 1 at saka si d sub n. So ibig sabihin parang tinatali mo yung mga coefficients ng cubic term dun sa first two pieces ng cubic spline at saka yung last two pieces. Kaya ang tawag dito not-a-not. Actually, not pala, no? So dapat hindi siya not. Hindi siya buhol. Alright? Yun yung gustong sabihin nito. Pero anyway, I don't know the exact etymology, ba yung iniisip ko pala, ngayon ko lang na-realize. Pero the condition for a not-a-not cubic spline, dapat yung d1 ay equal kay d2 at saka yung d sub n minus 1 ay equal kay d sub n. Alright? Ano nga ba itong mga d sub i's? Remember, yung mga d sub i's coefficient ng cubic term doon sa ating bawat piraso ng cubic spline. Right? Now, how do we do this? Well, paano ko makukuha yung last two, yung nawawalang dalawang rows doon sa ating coefficient matrix? Well, what I'll do is I'll use equation 4.7. Ang sabi ng equation 4.7, ang d sub I daw ay equal kay c sub I plus 1 minus c sub I over 3h sub I. Kasi ngayon, ang meron akong conditions ay conditions para sa mga d sub i's. So, kailangan kong humanap ng relation ng mga d sub I sa c sub i's. Kasi gusto kong i-insert etong condition na to sa isang matrix system ng unknowns ay mga c sub i's. So, meron akong imposition sa mga d sub i's, pero kailangan ko siyang i-connect sa isang linear system na ang laman ay mga c sub i's. So, kailangan kong humanap among the equations that we have so far na magko-connect kay c sub i's at saka kay d sub i's. And among those, I found out equation 4.7 directly relates d sub I in terms of the c sub i's. Alright? So, ibig sabihin, kapag ka si I ay equal kay 1 at saka kay 2, alright? Ibig sabihin, si D1 ay equal kay C sub 2 minus C sub 1 over 3H1. Tapos, si D sub 2 naman ay equal kay C sub 3 minus C sub 2 over 3H sub 2. And then the not-to-not boundary condition requires D1 to be equal to D2. So these two guys must be equal to each other. Okay? Tapos, gusto ko lamang i-arrange to in a nice way. So, pag in-arrange ko to in a nice way, do your algebra, multiply both sides by 3h1, h2, then collect all terms sa kaliwa, you will get this guy. Okay? Tapos, meron na ako ngayong additional equation. Makukumpleto ko na. May additional na akong isang equation kasi kulang tayo ng dalawang equations. Now we got one of them. Right? Equation involving the c sub i's. So, ibig sabihin, in this equation, si c sub 1 dapat nakamultiply ng h2. Pero si c sub 1 dito sa ating matrix system ay namumultiply sa entry sa first column ng first row. So, si h2, ilalagay ko dito. Tapos, itong multiplier kay C2, ilalagay ko dito sa second row. Kasi pagka minultiply ko itong row na to by this column, right? The first entry gets multiplied with the first entry. Second entry gets multiplied with the second entry. And third entry gets multiplied by the third entry. Then you get the sum, right? So pag minultiply ko to at saka ito, I'll get this minus that minus that. Alright? Pag kinuha mo yung multiplication na yan. Tapos equal daw siya dapat kay 0. So put a 0 into the right-hand side. Okay? Tapos, pagka ginawa niyo yung same analysis pero for I equals n and n minus 1, pag inimpose niyo ito naman yung makukuha nyo, tapos i-arrange ko naman to ngayon. Si c sub n minus 1 dapat mamultiply ng hn. Pero si c sub n minus 1 ay third from the bottom row nung unknown vector. So, ibig sabihin, nandun siya sa third to the last column. Tapos, ito naman, yung negative h sub n minus 1 plus h sub n, siya yung nandun sa penultimate column. Tapos, ito naman, siya yung nandun. Alright? Tapos, equal pa rin kay 0. So, may 0 dyan. So, now, you have completely determined your linear system. So, kapag ka wala ng ibang information dun sa data na ginamit nyo, alright? So, ang gagamitin nyo na, or ang usual na ginagamit ay not-a-not cubic spline. And the coefficients for the not-a-not cubic spline can be obtained by first solving equation 4.12, which will give you the c sub i's. Pag na-compute nyo na yung mga c sub i's, mako-compute nyo na yung bi's at saka yung d sub i's. And it is guaranteed that the d sub 1 will be equal to d sub 2, and d sub n minus 1 will be equal to d sub n. Alright? Na overestimate ko yung time, 9:20 na pala. But I hope you allow me a couple more minutes just to finish everything up here, alright? Pero ganun yung idea, no? So, hinahanap lang natin yung dalawang nawawalang equations para ma-fill in natin yung top and bottom row nung coefficient, nung no matrix equation 4.11 para ma-completely determine yung equations, yung system of equations na magbibigay sa atin ng mga c-sabays. Okay? Now, aside from, so you have a bunch of examples here which you can try to recreate, all right? So I'll just put that as an assignment for you guys. So ito yung example ng not-a-not interpolation, right? So mga cubic functions yan na pinagdikit-dikit and continuous hanggang second derivative. Kaya smooth yung interpolant natin. Hindi katulad ng piecewise linear interpolants na may mga sudden turns at may mga cusps. All right. Now, another type of cubic splines is what we call the clamp cubic spline or the complete cubic spline. And you can derive the clamp or the cubic spline if you know the value of the derivative at the endpoints. So kapag aside from data points, alam niyo yung value ng first derivative ni f kay A at saka first derivative ni f kay B. Right? So you have these two additional information, then it makes sense na i-force din natin yung derivative ng ating spline to agree to the given values of the derivative. So ibig sabihin yung s prime of A ay dapat equal kay f prime of A at saka yung s prime of B ay equal kay f prime of B. Right? But essentially, S prime of A is equal to S1 prime of A. All right? So ito yung mangyayari. And then, pag kinumpute natin yung derivative ni S1, I remember si S1 of X ay A1 plus B1 X minus X1 plus C1 X minus X1 squared plus D1 X minus X1 cubed. Yan yung itsura ni S1. Pag kinuha ko yung derivative nito, tapos in-evaluate ko at at x equals a, makukuha ko sino? So derivative nito ay b1 plus 2c1 times a minus x1. Pero ang x1 natin ay a, ano? So kasi ang x1 natin ay equal kay a, so ito ay mag-vanish. Tapos derivative nito ay 3d1 x minus x1 squared. Pero si a ay equal kay x1, so mag-zero rin yung term na to sa derivative. So ito naman yung mangyayari. Si s1 prime of a ay equal kay b1. So ibig sabihin si b1 dapat equal kay f prime of a. Kasi nga gusto kong gamitin itong condition na ito. Okay? And similarly, we can show that b sub n must be equal to f prime of b. And then, para naman dito, kailangan yung gamitin yung equation 4.8 and 4.9. Okay? So, kapag ginamit yung equation 4.8 and 4.9, if you're patient enough with the algebra, you can come up with the following top and bottom rows. Okay. Ito yung madadagdag na information. So I want you to practice on this, ano? So tingnan niyo kung makukuha niyo yung top sa bottom row para sa clamp or complete cubic splines. Siguro sobrang haba na. Meron dalawang theorems dito, the minimum curvature property. Ang ibig sabihin lang ng minimum curvature property, yung clamp cubic splines, sila yung may pinakamaliit na curvature for all functions on the interval AB. So, ibig sabihin, sila yung pinakamaliit yung curve over the interval AB. Alright? Halimbawa ito, mataas yung curvature ng parabolas. Kasi ang taas ng pagkakakurba nung parabola. So, ito, mas maliit yung curvature niya kasi nga mas kakaunti yung kanyang curve. Alright? And then theorem 4.3 gives us the error bound for the clamp cubic spline. All right. So merong error bound para sa not cubic splines, pero hindi ko siya nahanap and I forgot why I didn't put it here. Baka nakalimutan ko lang siyang hanapin. Pero binigay ko dito yung para sa clamp cubic splines. Tapos may iba pa mga klase ng cubic splines. merong natural cubic spline. Yung natural cubic spline naman, ang second derivative ay equal kay 0 dun sa magkabilang endpoints. Alright? Ito yung additional condition na hanapin natin. Tapos, pwede na rin namang periodic. Kung periodic spline, ito naman yung idadagdag nyo na condition. So mula dito, makukuha mo yung additional 2 equations na hinahanap. Dito, makukuha mo rin yung additional 2 equations na hinahanap. So if you impose this condition, you'll get another type of cubic spline. Mahanap mo yung top and bottom row ng equation 4.11. And then what you'll get is a natural cubic spline. Kapag ka periodic naman yung condition na nilagay mo, makakuha ka uli ng dalawang equations. Then magagamit mo to para dun sa top and bottom rows ng equation 4.11. Or you can be as creative as you can and select additional conditions na magbibigay sa atin ng top and bottom row that will make the system have a unique solution. Then that could be your own cubic spline, right? So sa problem set, pwedeng magpagawa ako ng clamp cubic spline. Pwede rin ako magpagawa ng not a knot cubic spline or natural cubic spline na hindi ko dinerive yung top and bottom equation. So it's up to you to derive the top and the bottom equations. Pwedeng ganun yung pagawa ko sa problem set. So I hope that you got the idea of how to get the top and bottom conditions, all right? And then merong periodic cubic splines. And I guess that's the end of this module. So now, marami akong ini-skip. Is it okay if we still, kasi pwede tayo mag-meet sa Friday if you want, but another option is I can just share to you a recording of a more detailed session. Hopefully meron, titingnan ko yung discussions ko from last year, kung na-discuss ko in details yung etong mga parts na ini-skip ko. But I think you can read this on your own, all right? Yun naman yung kagandahan ng training. Yun yung gusto ko maging training nyo dito. May mga parts na dinidiscuss natin in details. Hopefully that you get the hang of reading the module or how to use the module so that if there are parts that we cannot really tackle live or during our sync sessions, pwede nyo siyang aralin. Kasi marunong na kayong magbasa ng isang mathematical text. Alright? So, show of hands. Sino yung gustong mag-meet pa tayo sa Friday? Para balikan yung mga detalye na iniwan natin. So basically, the idea there is siguro ipakita yung derivation ng clamp cubic spline. But this is purely algebra. Try to use equation 4.8 and 4.9 dito sa info na to and dun sa info para sa S prime of B. All right? You get essentially mirror images of each other and then you'll get the top and the bottom rows. So, okay. Or okay lang na kaya nyo na itong gawin on your own. I'll take a look at my recordings from last year and if there is a relevant video that shows the details for this guys or for the missing parts na hindi natin di-discuss ngayon, i-share ko na lang sa inyo. So anong gusto nyo? To klase or not to klase? That's the question for Friday. Sige, Sinong may gustong magklase pa tayo sa Friday? Taas ang kamay. O, di ba wala? So, alright. So, ganun na lang. So, meron si Christian. Pero nagbago isip niya. Nahiya na siya. Alright, so wala na tayong klase sa Friday. Yun na lang. What I'll do is to take a look again at the recordings from last semester, from last year. Kung diniscuss ko to in details, i-share ko sa inyo yung recording, so you can watch it. Pero expect the worst sa problem set 1.3 dahil sinabi ko na cubic splines yung lalabas sa problem set 1.3. So malamang, kasi yun yung heavy computation part ng lab XR malamang, ang ipapahanap ko sa inyo ang ipapagamit ko sa inyo ay natural cubic spline o kaya periodic cubic spline. So siguro first part ay hanapin yung nawawalang equations. So halimbawa sa cubic splines, sa natural cubic spline, pwede kong ipahanap yung dalawang equation na idadagdag nyo. Kumbaga yung analog nitong dalawang equations na to. So ito yung dalawang nawawalang equations sa not a not. So try to see what are the missing equations para makuha ko yung natural cubic spline. Dun sa not a not, dun sa clamp cubic splines, ito yung nawawalang equation naman. 2h1c1 plus h1c2 equals this guy. Alright? At saka, h sub n times c sub n plus 2h sub n times c sub n plus 1 equals this guy. Yun yung second na nawawalang equation para sa clamp cubic splines. So think of or try to see if you can derive it for the natural cubic spline. Kasi baka yun yung ilagay ko sa problem set. Tapos i-implement nyo to in real world data or with some interesting data na ibibigay ko sa prop set. Okay? Ayos ba yan? Alright, but anyway, you'll see the problem set. Sige na nga, para safe ako, no? So, by Friday, makikita niyo yung PS1, okay? So, ibig sabihin hanggang 11:59 p.m. kayo mag-aabang sa Friday. Or buksan niyo na lang siya sa sa Saturday morning, ano? And the ang deadline pa naman niya ay November 6. So, you have lots of time to finish this. Pero try to do it as soon as you can, all right? And then what I'll do is I'll have 3 different submission bins in Canvas. So 1.1, 1.2, at saka 1.3. Pwede kayo mag-submit per item. So pag natapos niyo na lahat ng essay questions, submit niyo na yung PS 1.1. Pag natapos niyo na yung proving or quick computation question, submit niyo na yung 1.2. And so on. Para hindi kayo natatambakan, at saka para pagka-free ako, pwede ko nang simulang checkan. Ano? So kahit wala pa yung ibang items. Alright? So overtime na ako ng 2 minutes. So again, no classes on may question si Mitzi, magko-code pa po ba sa prob set? Yes, Mitzi, you might need to code kasi dun sa problem 3. Sa part 3 ng lab exer, sabi ko nga cubic splines yung papagawa ko doon. So kailangan nyo ng program para sa cubic splines. Unless kaya nyo siyang gawin ng mano-mano. Pero baka 10 points yung ibigay ko sa inyo. So meron kayong 11 by 11 system, hindi siya magandang gawin by hand. Alright? Pero kailangan niyo yan. Okay? So if there are no other questions, then thank you guys for joining me today. No classes on Friday. So that means we'll meet each other again on November na, no? Tama ba? November na tayo mag-meet. November 2nd. All right. So enjoy the reading break. Enjoy the long Halloween weekend, ano? And then keep safe and let's see each other on November 2nd. All right. Bye guys.